Okay, so what I'm going to do is I'm going to take everybody through a brief SD-WAN tutorial in the remaining time we have, but I also wanted to talk to you about the work, the standardization work that we're doing in MEF regarding SD-WAN, and as Rami mentioned earlier, really encourage you to to join that work, because this is very unique in the industry. We're probably we are the only industry fora standards body that's working on SD-WAN on the managed services side, so SD-WAN for service providers as opposed to enterprise SD-WAN. So I want to take you through some concepts. I'll take you through some of the functionality and components that we're defining in MEF, and then I'll take you through some specific how does SD-WAN fit into the MEF LSO reference architecture, which if you attended the earlier sessions, I'm sure that was covered there. And then I'll go through some use cases on how that fits in the architecture. So moving forward, in order to understand SD-WAN, you have to understand the concept of overlay and underlay networks. It's kind of a fundamental thing. It depends on your background, but when people think of a managed service, a managed network service, you're normally thinking of like circuits, carrier Ethernet or optical connections. But when you move into the SD-WAN space, you're now talking about a virtual overlay. And let me explain what I mean by that. So the underlay, this terminology, those who have been doing work in the data center environment, understand that, the underlay and overlay network concepts. But now we're moving it out into the sort of the service provider space, and so that terminology might be not as relevant or not as well understood. So the underlay network referring to in general to the physical transport network, and then the overlay network is really your virtual network that you run on top of that. The important thing to take away from this is that when you're building a virtual overlay, that is, you're abstracting the service from the network. Let me explain what I mean by that. So if I buy a T1 circuit today or a carrier Ethernet connection, there's a one-to-one correspondence between the service and the network, right? So if I get a T1, I get a copper line in. The T1 is the physical network, but it's also the service that I have, or DS1 service, however you want to call it. But same thing with carrier Ethernet. If I'm getting carrier Ethernet over fiber and I get that carrier Ethernet circuit, the service is the same as the network in that case. In the case of SD-WAN, the service is decoupled from the physical network, right? So the analogy of a T1 being both the physical underlay network and the service does not apply here. I can run an SD-WAN over any type of physical network. Okay. The other thing is overlay networks are tunneled. You hear the term tunneled or virtual overlays, and they use some type of an encapsulation protocol. In the data center, very popular, using VXLAN or NVGRE. In the case of SD-WAN, more commonly used IPsec. But the bottom line is it's creating a tunnel that runs virtually over that underlay network. And the underlay network not only is the physical network, but it could actually be like an IP layer, which it most often is for SD-WAN, which is not a physical network, obviously. So it's a virtual overlay over a virtual network in the case of IP. So there's multiple dimensions of this. And as I mentioned earlier, the overlay, underlay terminology is common in the data center environment, but now moving it, into the SD-WAN or WAN in more generally. But now the interesting thing is, carrier Ethernet, I mentioned earlier, being an underlay technology, the way the MEF has defined Ethernet services is independent of the transporter underlay network. So we were kind of there, 15 years ago when we were 16 years ago when we first started defining Ethernet services, because we didn't tie it to the physical underlay network. So what is an SD-WAN? Let's take this and break this down sort of into elemental components. So one of the challenges is there's a lot of marketing hype around this. Everybody calls what they have an SD-WAN. Like, what really is an SD-WAN? Can I go and find out what the formal definition is? And unfortunately, no. But there are some characteristics that an SD-WAN has, right? So one is, one definition you'll see is it's a specific use case, for example, of SDN. And because it uses SDN constructs and concepts in order to deliver the service. The second one, as I mentioned earlier, is a virtual overlay. So it runs on top of either the public internet or it'll run on top of a VPN, like for example, an MPLS VPN service. So it'll run on top of these services. And I'll show you through more use cases on this as well. The other thing is it's independent. Since it's independent of the transport, it can run over wireline, wireless, optical. It doesn't matter what the physical underlay is. So you can do an SD-WAN over Wi-Fi, you can do over LTE, eventually 5G, as well as your typical fiber optic networks or copper networks. It doesn't matter, wireline, wireless. And as I mentioned earlier, it's abstracted from the underlay network, so there's no interaction. This is a really, really important point because anybody can deliver an SD-WAN service because it's abstracted from the underlay network. What I mean by that is I can be a virtual network operator and deliver an SD-WAN service without owning any facilities because it runs over, I can connect it all up over the public internet. So everybody has an internet connection, so I can deliver an SD-WAN service that way. And so one of the key things, we have a project, it's called our OpenCS SD-WAN project, and we're working on standardizing the definition of SD-WAN, what are the key functional components of SD-WAN, and then how does it fit into the MEF LSO reference architecture, so where the different APIs fit, which I'll cover in a moment. So if you're really interested in driving this forward in the industry, join our project. We have a call every Thursday morning at 8:30. And it's a great project. It's just a half-hour call, but we get a lot done, and it's a way for you to really put your fingerprints on really driving this forward because it's such an important area. Now the SD-WAN service component, so we now have to break this down. So you have this SD-WAN service, kind of this virtual overlay thing, right? And now let's take a look at the components. So there's a couple of important components here. One is what we're referring to in the MEF in our project as SD-WAN Edge. The SD-WAN Edge is where the SD-WAN service begins or ends. And we're not calling it physical or virtual, we're just saying Edge. We're not saying Edge CPE or Edge whatever, it's just Edge. What happens here is all of your policy enforcement, traffic steering over different WANs, your DPI, your deep packet inspection for classifying the applications to determine, do I go over this WAN or do I go over that WAN? Your QoS and security policy enforcement. So all policy enforcement has to be done there because that's where it first enters your particular WAN connection. Then you have your SD-WAN controller, which is basically your centralized control. So it pushes down your config, your policy, what policies that were configured, we get pushed down into the SD-WAN edges. Your SD-WAN orchestrator is really where you set up your policies, where you set up your network connectivity, and that gets pushed down again to the controller, then to the edges for different traffic routing purposes. And then finally, your SD-WAN controller has, if you think about throughout this event, you're probably going to hear, self-service, customer portals where you can go in and actually change the service, like a cloud service. That's a kind of an integral part of an SD-WAN service, and so that has to go through, the orchestration layer. So if we take a look at, I took kind of the functional components, but let's take a look at the functionality, and we're still in the process of defining all of this in the project. But as I mentioned earlier, an SD-WAN service does traffic steering over different WANs, for example. So these are done via encrypted tunnels. So you can send it over the internet and be secured because the tunnel is encrypted. You can and it can run over any different type of WAN. So you can use low-cost broadband. You can use a DIA, dedicated internet access service. MPLS VPN or the physical layer, LTE or Wi-Fi, which would then go over the public internet. The SD-WAN service can operate because it's decoupled from the underlay network. It could run over any ISP or any whoever provides that access network. It's independent of that, right? Because there's no interaction. The example I like to give for this is, I think there was a session in the Intel Builders. A gentleman from Verizon mentioned. If you had to buy a service and you had to go, you were running an application, like the example I like to give is, if you're running Netflix, you want to be able to run Netflix, but you had to call up your ISP and say, hey, I want to run Netflix on this network. Can you adjust the network and adjust the QoS and all that? You don't do that. That would never take off. So the SD-WAN is very similar, where you don't have to coordinate with the underlay network or access network provider. Real-time QoS. So service assurance is a really key part of an SD-WAN, because you have to, when you're setting up your QoS policies, you have to decide, do I go over WAN A or WAN B based on those real-time measurements, right? So I'm measuring latency, I'm measuring loss over those connections. And so if I have applications that require a certain QoS, maybe I'm running, Skype for Business, or I'm running GoToMeeting, or whatever my application is, maybe if it's real-time media, it has certain QoS requirements where if they're worse than that, the application just won't function properly. And so by making these QoS real-time measurements, you can go in and say, oh, okay, this internet WAN connection met those requirements, and now I can send Skype for Business over that connection. The application-based traffic steering. So unlike most managed network services today, it's up to the enterprise or the subscriber to actually go and mark the traffic, right? They have to, if they're buying a service and they get, gold, silver, bronze, 3 classes of service, it's up to them to say, oh, okay, I want my SAP application to be gold. I want my Skype for Business to be silver, or whatever class of service. So they have to go and do the deep packet inspection, and they have to go mark the diffserv code point or the priority code point at the network level. They don't want to do that. That's expensive. That's not what they want. They really want to focus on the application. They want the application to basically, say, I want my app to work, and I want to set up a policy that says, okay, send it over this WAN if the QoS performance meets the application needs. Another type of, so in this case, if I have a policy, for example, and I'm saying, why don't, I can send my Skype for Business traffic, I'm constantly measuring the QoS metrics, and I can send it over my internet WAN link instead of my MPLS VPN WAN connection if that measurement says my packet loss is less than a certain amount and my packet delay is less than a certain amount. So you can make those decisions in real time based on the QoS measurements, or setting up a QoS policy where I could say, I want to block all cloud storage. I don't want people to go to iCloud.com or Box.com, et cetera. The other key aspect is zero-touch provisioning, and this is really to make it just like a residential service, right? Today you get shipped a cable modem or a DSL modem at home, and service providers have been able to scale quite extensively because of the automation, right? They need, in order to scale on the residential side, you have less sophisticated customers that just need to plug in power and the cables, and it just needs to work. The same thing with SD-WAN is taking on that philosophy. So really have that same level of automation versus sending a technician out and they have to go and do things. So let's talk about some of the benefits from kind of the buyers and the sellers of the services. So why an SD-WAN service? So if you look at the subscriber benefits, so this would be the enterprise like subscriber who actually buys the service from a communication service provider. So one of them is clearly a large OpEx savings. And so MPLS VPNs are probably about 10x the price of broadband internet, maybe even more than that, maybe 20x depending on where you are in the world. And so they want to be able to take, steer some of that traffic over the expensive MPLS VPN and move it over to, let's say, an internet or broadband connection that's much cheaper when those QoS policies are met for the application. The second piece is application-based. So it's application-based, so it looks at applications, so you don't have to, the enterprises can just say, I want, Skype or Outlook or whatever the application is, I want it to go over this WAN or that WAN based on my QoS or security policies. Another key aspect is because it's plug and play in terms of the zero-touch provisioning, no interaction with the underlay network of the access provider, you can add a new site or a remote or temporary site very, very quickly, and you're just using the internet or LTE. So for example, if you need to set up a kiosk in a mall someplace, you can set that up, connect it up to the SD-WAN over LTE, and literally in a couple of minutes you can have the service set up. And then achieving high availability and path diversity. So you won't be able to say, well, whether it goes in conduit A or conduit B out of a building, but by having multiple WANs, maybe multiple internet, multiple ISPs coming in, and an MPLS VPN maybe from the access provider there, you can run. You have that different diversity where you can send your traffic. So let's take a look at the other side. So that's the subscriber benefits. So the service provider actually selling the service. So again, the OpEx. So OpEx has always been probably the highest cost for a service provider. And so the zero-touch provisioning, if you think about going out, sending a technician out, at whatever, you pick your price, $50, $100 an hour or whatever for a truck roll, they're out there 2 hours, all of a sudden that's 1 or 2 months worth of service. And having the self-service portal, so following that same model like the cloud, for you to be able to go into self-service portal and actually make changes, empower your subscriber to actually make service changes, and it doesn't require any back-end changes from anybody in the network, so you don't have to have personnel, it's all automatic. Faster time to revenue. This is probably a huge one. So if you think about when you're delivering a new managed network service, even if you have facilities into the building or a peering agreement with the access provider, it still takes a minimum of probably about 30 days to deliver that service. Even though the facilities are there and you can ship the CPE out, just getting all the back-end systems, getting everything all set up, it takes a while. So that's not only but even for adding off-net sites is a huge benefit. Because if you think about, on-net, it's one challenge, but off-net, when you have to peer with another provider, if you already have an agreement in place, it might take 30 days. But if you don't have an agreement in place, you might have to walk away from a bid if you're a service provider and 20 of your sites are on-net and the 21st site is off-net. You might say this is just it's going to take too long or too expensive in order to be able to do this and walk away from that. And then finally, I'm going to be talking a lot more about this on Thursday, on my session on Thursday, but one of the comments that was brought in, I think one of the speakers in the Intel conference, I can't remember who it was, but SD-WAN enables new types of service providers to enter the market. So think about if you're a cloud service provider, you're not a network service provider like a traditional telco, you're a cloud service provider, well, people have to connect to your cloud. If it's Amazon has a VPN service, but if you're a cloud service provider and you're hosting infrastructure as a service or whatever, people have to connect into a network to get in. Why not offer a secure VPN type of service using SD-WAN as the technology for that? So again, they're a virtual network operator. Yeah, sure, they have an internet connection, but they can't reach all the sites via any kind of private connection. So now let's go through the MEF LSO reference architecture and see where does SD-WAN fit into this and what are all the touch points, API touch points and interface points. So again, if you attended the earlier sessions, you would have seen a similar functional architecture for the service orchestration functions, et cetera. So first of all, when a subscriber is ordering a service, or this is the first time the service is ordered, they go through the LSO Cantata interface. And that would go to the business app. So for example, if you log into a customer portal, you have to be authenticated. Do I have an account? Am I past due on any of my bills? Can I use the service? Am I authorized to use the service? Once that happens, then through the Legato interface, you go down and say, okay, you've passed that test. Let's go ahead and set up that service through the service orchestration function. The service orchestration function then goes down to the SD-WAN controller, and instructs it to do its magic to go down and touch the endpoints there. So in which case you use the LSO Adagio to talk to the SD-WAN edges. Now once that service is up and running, you don't have to go back and authenticate again. If you want to make a service change, you're logged in, you want to make a service change, I want to change the amount of SD-WAN bandwidth I'm allocating to WAN A versus WAN B, for example. I would go through the LSO Allegro interface, and then now I can bypass the business apps. I don't have to do that. Go into the service orchestration function, and then follow that same path down to touch and reconfigure those SD-WAN edges with the new information. Now, the LSO Presto interface is the area where we're focusing on in this project. And with this interface, it enables the service orchestrator really to manage different SD-WAN controllers. So I'll show you a use case a little bit later, but if in this case I'm showing, let's say it's all one vendor's technology in there, now I can use Presto. Once we have a standard way of doing Presto, if all of the SD-WAN vendors conform to the Presto API, now I can go and have another domain with vendor B to be able to plug in their SD-WAN and push down when I'm ordering information or setting up an SD-WAN, everything's abstracted through the API. And then the SD-WAN controllers manage their particular domains for that. And this is basically the project that I was talking about we're doing the MEF. We're focusing on the LSO Presto interface and be able to define the data model for that to determine which artifacts, what information needs to be passed down through that API in order to configure and set up and do service assurance for an SD-WAN connection that's managed by that domain. So now we'll take a little bit, wrap this up with a couple of use cases. So again, the same functionality that I talked about before. Let's say I'm setting up a service, but in this case, I'm using a virtual SD-WAN edge. So for example, and this one is my traditional SD-WAN CPE, so a PNF, physical network function. In this side here, I'm using a virtual network function, and instead of using a CPE device, I'm actually running this VNF inside my cloud instance. So imagine you have a workload running in an Amazon EC2 instance, in Amazon Web Services, and you want that SD-WAN connection to go all the way from your one enterprise location here, everything's secure inside the building, but this is public cloud, and so I want to run that, and so now I can put the VNF, the SD-WAN Edge VNF, run it right inside my EC2 instance, so it's secure all the way up to my workload. This is huge potential here. And then, so in this case, because I have a VNF, through my Presto API, I can talk to an NFV resource orchestrator that goes and spins up the VNF on that compute instance there. And then I would go and then set up the SD-WAN end-to-end for both of the edges, on the physical CP on the left side and the virtual SD-WAN edge on the right side. And then again, if I'm making a service change, I can go through the same motions like that as well. So powerful use case, because if you look at WAN services or managed network services, they typically terminate on physical devices right at the building, as opposed to reaching in all the way inside the building. So let's take a look at, so that was a case of a VNF running actually on a server. This is a case of a vCPE. So again, I have my traditional SD-WAN Edge CPE here, and then I have an SD-WAN Edge virtual CPE here, in which case it's front-ending the right into the building for both of these. And so in a similar way, I would go through and set up the service through an NFV resource orchestrator, actually very similar to I did the previous use case, although in this case, it's not running inside of a public cloud. It's just running on like a white box CPE that runs multiple VNFs. So in this case, I have my SD-WAN VNF that I spun up here. But I do have the ability to add more VNFs. So let's say I want to add a managed security service on that as well. I can now use the same Presto API that spun up my SD-WAN Edge VNF, and I can go spin up a security service. So all through a customer portal, the customer now self-service. They can spin up now a second service that generates revenue as well. And again, being able to set up the SD-WAN, modify the SD-WAN service as well. Okay, now I think this is the last use case. In this use case, where you have multiple vendors, so now you have two SD-WAN vendors in the picture here. So the other ones I was showing a single vendor approach. So again, I would be setting up a service, but in this case, I can have, let's say, vendor A's domain, which is they're controlling their SD-WAN edges, and this is their SD-WAN controller. And again, they support. It's all abstracted through the Presto API to be able to set that up. And then through that same API, I can have SD-WAN vendor B talk to their SD-WAN edges, whether they're physical or virtual, it doesn't matter. And now I can modify the service and be able to set up an end-to-end SD-WAN connection across two different vendor domains, SD-WAN vendor domains. Again, all abstracted through the Presto API, because I'm just instructing them to set up the edges, setting up the policies in a consistent and common way. And that's the benefit you get from the API. And so again, the focus on the Presto interface, so that it's really critical that northbound, the SD-WAN controller support the Presto API, and then each domain is managed independently. But through that Presto API, I can set up that end-to-end service across different vendor domains. Okay. So key takeaways. SD-WAN, a virtual overlay service, has no interaction with the underlay, runs over any type of access or transport network. So very powerful, because it's very similar to over-the-top applications where, because there's no interaction under the network, you can run it over any environment. The second one is there are huge benefits. I listed many of them on a prior slide, but I think service agility. We're talking about the third network, the MEF, the third network services. We're talking about agile, assured, and orchestrated. And I would argue that an SD-WAN service a managed service is the first third network service because it hits agile, assured, and orchestrated. And then finally, we really want to move this forward. There was a great panel session earlier about standards versus open source, fast versus slow. And I think we really have we're at an opportune time here to really drive this forward and create this level of standardization in this SD-WAN industry, tying it into the MEF LSO reference architecture. So not only can you spin up SD-WAN services very quickly, but also spin up other NFV-based or VNF-based services, virtual network services, using that same infrastructure environment. So that concludes my session, and I don't know if there are any questions. Question here. I'm sorry, could you say it a little bit louder? Oh, here's the microphones coming right here, okay. Just speak up, sing. Oh, okay, they're recording it, okay. Right, okay.
For the SD-WAN edge. There's also, that's for the overlay, correct? And there's also actual physical CPU for the underlay as well, is that correct?
Oh, okay, so I'll repeat the question just so. So the question is, there's the SD-WAN edge, which could be a CPE or VCPE, which is a physical device. Is there another CPE device for the underlay network? And so the answer is it could, and let me explain that a little further. So for example, if there's already a underlay network in place, carrier Ethernet, there's probably a NID, Ethernet NID on the customer prem, or if there was an internet access service already there, there's probably a router already there, a physical router, for example, and then you would put your SD-WAN edge, kind of behind it, right? So that's the one case, but the other case though is if the same service provider who wants to deliver a new service also delivers the underlay network, then they can actually incorporate that all in, like in the case of VCPE, they can incorporate, a router, they can have their SD-WAN edge VNF and any other VNFs that allow them to terminate the service as well. So the answer is it depends whether it's brownfield or if it's a greenfield, new deployment, and if it's greenfield, whether that service provider also provides the underlay access network as well. Okay, any other questions? Okay, well, thank you for joining today, and I'll be around the rest of the week for if anybody has any questions they think of.